Swayam Prabha. Digital India. Educated India.
Warm welcome to my friends, my dear students. A very good morning, good afternoon, good evening to all of you. And as you know, this is the 33rd lecture for the TQM1 lecture series under NPTEL MOOC. I am Raghunandan Sengupta from IME department, IIT Kanpur. So, if you remember, we were discussing the charts in details as you change that, like charts like X bar charts, R charts, P charts, C charts, NP charts, G charts, H charts, and technically in all the charts what you actually need is an average value. Now, the average value can technically come from the population or from the sample, and when you pick up a sample you have to find out the best estimate with respect to the population. And there I did mention very fleetingly the concept of unbiased estimates and the minimum variance concepts also. I just mentioned them in words, I did not go into details. So, which should be the best estimate from the sample to mimic the population parameters. So, the parameters was basically the mean, and then that is the central line, and then you have a upper control and a lower control. So, the upper control line and the lower control line would basically depend on the case that what is the overall level of confidence you want to have. So, if it is plus minus 3 sigma, then the multiplication coefficient would be 3, plus and minus being coming for the positive side and negative side. It was 4 sigma, so obviously plus minus 2, and if it was 2 sigma it would be plus minus 1. Now, the sigma value which you will find out in the initial case when we started was basically the range or R, because in that case the range would give us the average value and also a plus minus range values, and then you can find out the range values given the average value of the range multiplying by the values of A1, A2, A3 or B1, B2, B3 or C1, C2, C3, whatever the case be, and those constants, these A1, A2, A3 or B1, B2, B3, C1, C2, C3 would depend on the sample size. Later on, next we saw that we used the concepts of the standard deviation being known, not known, then we went into the C charts, then we went to the proportion charts and the proportion charts and the C charts, and later on we saw that how the central limit theorem could be utilized, considering that the actual distribution was binomial, how you can take the mean value and the standard deviation of the binomial distribution as the mean and the standard deviation of the normal distribution based on which you are trying to draw the charts. And later on we also saw that in case proportions are not available, we took the n into p values, which is the total number. Then we also saw that if the samples were themselves changing, like in the first set we have n1 samples, second set we have n2 samples, so on and so forth, how we can do the calculation. The calculation remains the same, only the division part in one of the calculations where you want to find out the standard deviations, it will be divided by ni depending on whatever the I is. And in case you want to take the average, we find out the average of all the ni's and add them up, divide by the number of such samples, and we find out n bar. Then considering all these things, we also later on considered different problems in a very small set, and how this R programming could be utilized to find out the graphs, the process control charts, and in case if n is also changing, like you are eliminating n or adding one n, so that would also be coming under the concept of ni. So, to continue the discussion further. So, now we are considering the process capability ratios and the associated process fallout depending on the overall errors which you have. So, the process capability ratios are given on the first column PCR starting from 0.25 till 2, then one-sided specification, two-sided specification would be given. Now, the reason is that, say for example, there is, let us discuss two separate examples which will be better for us to understand. Let us consider one tie rod, and the tie rod has to be fitted in some machine parts. Now, consider the machine part has a length of, say for example, 2 feet. So, technically it would mean that the tie rod has to be exactly a little bit less, some microns or some nanomillimeters less than the 2 feet. Now, if that is the case, then obviously the fitting would be exact, but in case, say for example, the length is much more, so obviously the tie rod would not be fitted, because then some material, extra material has to be again adjusted and then fitted. Now, it may so happen that if the length of the tie rod is much less than some few estimates than the microns, meaning microns or nano centimeters, whatever it is with respect to 2 feet, then obviously fitting that tie rod into that gap would be difficult, because you cannot basically add any materials, because the materials have been removed using either lathe machine or CNC machine or grinding machine, whatever it is, such that it becomes a waste. So, in that case you will be only interested in to find out the errors on one sided, provided if it is less, then obviously it becomes a wastages. If it is more, then obviously you can find out some method to remove the extra amount of material, raw material whatever is, and then basically fit it. And these type of examples can be thought of in such a way that the one sided and the two sided process control and the charts would be applicable. So, having said that, I will try to draw both the figures using the normal distribution, which will make some sense. So, consider the one sided, it would be either the side of an upper tail or the lower tail. So, I will use some other diagram. So, this is the lower tail, and in other case you have the both sides, it will basically be so it will be this side and this side also. Now, where the graphs look same, so you have a left tail, right tail in both the cases. So, where the interesting part is now, I will try to highlight using a different color. So, let me basically take the violet one. Now, in this case, if they are a left hand type, then obviously the whole area, let me try to find out the color scheme. So, the whole area onto, oh, this is yellow. So, whole area onto the right hand side would be included here. So, in case if my probability values are, say for example, alpha here, then this whole area becomes 1 minus alpha. In the other case, let me use a eraser to remove the yellow color, removed, this is also removed, this is also removed. Oh, okay. Sorry, we urgent basically bring the distribution as per se. I will try to draw it, yes, back into action. So, now if I am looking at the distribution on from the right hand side, so this will become, I will use again a different highlight color, not yellow, let me use the blue one for the time, yes. So, if I have this, the area now would be on the right hand side, which technically means that this is now alpha and this is 1 now 1 minus alpha. So, they are divided in proportions of alpha 1 minus alpha, but they are divided onto the left part or to the right part, not in between. So, what I mean by non in between, I will come to that. So, let me erase this blue part, because then it will be less confusing for us. Now, consider the second diagram. in this case the highlighted part would be, let me use the color as yellow. So now it will be this portion inside, and this would be highlighted. So this would be okay. Again, let me not continue the, sorry for that, because the color is changing, so please bear with me. So I will remove this yellow color, bring the red color into the picture. This will be alpha by 2, this will be alpha by 2, and this would be basically 1 minus alpha, which means that because this being a normal distribution, both the upper tail and the lower tail would be proportionally divided. In case if it was not a normal distribution, obviously the middle portion would be 1 minus alpha, and the rest alpha would be divided in some proportion onto the right hand side, means above the red one and below the black one, and below the black one, those vertical lines. But this being a symmetric distribution, alpha, that value of alpha is equally distributed onto the right and the left, hence it is alpha by 2. So that is why it mentions one sided specification and two sided specification. So I spent about 10 minutes talking about that, drawing different diagrams, was because this was the reason. So you have the process capability ratios are given, then the one sided and the both and the two sided specifications are basically given accordingly. Only one thing remember, the values which you have would be almost twice of each other. So if you are basically considering the values of 0.0009, so for the two sided one it just would be about double of that. If you are considering, say for example 484, it should be about 968, but it is 967. So that those values of plus 1 as 1 has been adjusted to make it approximately values exactly. So the PCR values would basically dictate either the one sided or the two sided, depending on how the case is. Now considering the assumptions, the quality characteristics has a normal distribution, as we have been discussing time and again. The process is in statistical control. So depending on the points which are above the upper control, lower the control, we will basically take actions accordingly. In the case of two sided specification, the process mean is centered between the lower and upper specifications as mentioned. So that means there is a central line, you have an equal proportion above, equal proportions below. So if you are looking at the charts, so these is this dotted one is the central line. So if you have upper control, lower control, the charts would be accordingly done. So these assumptions are absolutely critical to the accuracy and the validity of the reported numbers, and if they are not valid, then the reported quantities may be seriously in error. So stability or statistical control of the process is also essential to the correct interpretation, to have a correct interpretation about the PCR. What we actually observe in practice is an estimate of the probability, the ratios which we are talking about. The estimate is subject to the error in estimation, since it depends on the sample statistic. So it recommends minimum values of process capability ratios for existing process. If it is 1.3, one sided would be 1.25. In new processes, if two sided is 1.5, one sided would be 1.45, and so on and so forth. The values are given. So process capability analysis using control charts are done accordingly. Histograms, probability plots, and process capability ratios summarize the performance of the process. They do not necessarily display the potential capability of the process, because they do not address the issues of statistical control per se. The control chart should be regarded as the primary technique of process control capabilities analysis. The X and R chart should be used whenever possible, because of the greater power and the better information they disseminate and the overall information which you get. However, both P, C or the U charts are useful in analyzing process capability and trying to find out the proportionally concept, which is an intrinsic part of, say for example, an go no go gauge or bad and good items and all these things. So let us consider an example. So glass container strengths are given. You take one sample, size is basically 5 in number. So the first row gives you 265, 205, 263, 307 and 220 are the values, and you have basically taken 20 samples. So 20 into 5 is the total number is 500. for each row for each sample you find out the averages, which comes out as given in the second last column, which is x bar. So, the first value is 252, the last value is 253. So, from summing them up, dividing by 20 gives you the x double bar, which is actually the average of the averages of the sample, or technically if you have taken a huge number of samples repeatedly with each sample size being large, then this value of 264.06 would be exactly equal to the population average. You also find out the range. So, range are given on the last column starting from 102 to 70, and the average range value is given as 77.3. So, if you have the do the calculations, find out the x bar charts, the upper control is given by this x double bar plus A2 R bar. So, the A2 values which we have discussed, and I just discussed when we were in the initial slide, which was showing the 33rd slide. I did not mention that they depend on the sample size. So, depending on the sample size, I find the upper control as about 308.66 and a lower control as 219.46. Similarly, for the R charts, the values, average values is 77.3, the upper control is 163.49 and the lower value is basically 0. So, once you find out, you can find out the process parameters, and then basically if you compare the process parameters, if they are actually really close to the x double bar value for the mean value, and for the sigma value, if R bar divided by the D2 value, small d2 value, whatever it is depending on the sample size, which comes out to be 33.23, if it is closer to the overall population standard deviation, we know that the calculations and the process capabilities have been done as per the norm. So, let me continue reading it. The figure which we will see later on represents the values of x bar and R charts for 20 samples. Both charts exhibit statistic and control. The process parameters can be estimated, and they are stated, which I am again repeating. Mu hat basically means the best estimate for the population, which comes out to be, again I am repeating, is 264.06, and sigma hat, which is the estimate for the standard deviation, comes out to be 33.23. So, if you find out these charts and draw them for the x bar and the R charts, they are given as shown in this slide. So, the first one basically measures or find out x bar, the second one basically finds out the range. So, thus if you can find out one sided and two sided process capability would be basically you are trying to find out the difference between the mean and the lower control values divided by 3 sigma, and if you trying to find out the both sided process capability, it will be the upper control minus the lower control. So, in case if it is a normal one, what you are trying to do is that for both sides you are taking the whole so called difference between the upper control lower control value depending on what the value level of significance or level of confidence which you have, and in case if it is one sided, obviously it will be one half of the this total two sided concept which you have. So, in one case technically it is you are trying to find out the overall and the distances between the mean value and the lower control, or the mean value and the upper control depending on whatever the case is, such that you are able to cover that area in such a way that it will give you the one sided values, and in another case you can find out the difference using the two sided, such that those one sided and two sided example which I gave would make much sense to find out the process capability and the process characteristics of the charts. Conclusions: this example illustrates what we have just shown, illustrates a process that is in control, but operating at an unexpected level. So, obviously corrective actions needs to be taken. There is no evidence to indicate that the production of non-conforming units is operator controllable. Engineering and or management intervention would be required either to improve the process or to change the requirement if the quality problems are there with the bottles and they need to be solved. The objective of this intervention is to increase the process capability ratio at least to a minimum acceptable levels. The control charts can be used as a monitoring device or logbook to show the effect of changes in the process on process performance. Sometimes the process capability analysis indicates an out of control process, and the last point which is mentioned here in the slide, it is unsafe to estimate the process capability in such a case. The process must be stable in order to produce a reliable estimate of the process capability and thus find out what are the values of the parameters, or better still we want to find out the values of the estimates from the sample which would be the best estimates for the parameters of the population. So, process capability using design experiments, which we will consider this concept of design of experiments we will consider in more details in TQM2 course. Just for the information, I did mention when we started TQM1 course. A design experiment is a systematic approach to verifying the input controllable variables in the process and analyze the effects of this process variability on the output. Design experiments are also useful in discovering which set of process variability is influential on the output and what levels these variables should be held to optimize process performance. One of the major uses of design experiments is to isolate the values and estimate the sources of variability in a process. For example, consider a machine that fills bottles with a soft drink beverages. So, each machine has a large number of filling heads that must be independently adjusted, and you can basically find it out accordingly. The quality characteristics measure is the syrup content in the bottles of the finished products. So, they can have a variability due to the observed values, due to the machine variability, due to the head variability. So, there are different type of not problems, variability can occur, and you want to find out basically the variability of the observations, which technically would be the sum of all the variabilities. Now, remember one thing, adding the variance would give you a better estimate of trying to find out the variability, not adding the standard deviations. So, this should be mentioned. I am just mentioning it as an important point. Whenever you are trying to study any variability, adding the variance is the right way of doing it mathematically, doing it the right way, rather than adding the standard deviation. So, few explanations to continue that. An experiment can be designed involving sample from several machines and several heads on in each machines and making several analyses on each bottle, which would basically allow us for the estimation of the variances. So, if you consider this problem, let me use the color as it. So, in this case you have the machine variability, and then the variance is given by sigma square suffix m. In the second case you have the head to head variability, and this variance is given by sigma square suffix h, and the last one basically is the analytical test of the variability, and you want to find out of the variability considering the tests are being performed. So, what is the variability for them? So, this variability or the variance is given by sigma square suffix a. Now, as I mentioned, that add up the variability in finding out the total variability. So, to continuing that, suppose that the results appear as given in figure. Since a substantial portion of the total variability is observed and is due to the variability between the heads, this indicates the process can perhaps best be improved by reducing the head to head variability, and we will take corrective actions accordingly. This could be done by more careful setup or by more careful control of the operations of the machine. Now, we will further continue our discussion about process capability analysis using attribute data. So, technically we had considered whatever mentioned was related to the variability. Now, it is basically due to the attribute of the characteristics. When dealing with non-conformities or defects per unit, per 1000, per 100 or per lakh, whatever it is often used as a measure of the capability, and that is given by DPU, which basically means defects per unit, and that is given by the total number of defects divided by the total number of units. Here the unit is something that is delivered to the customer and can be evaluated or judged accordingly. Some examples include, say for example, preparation of invoice, a shipment, a customer order, and so on and so forth. The defects or non-conformities are anything that does not meet the customer requirements as given. They can be an error in invoice, they can be, say for example, incorrect and incomplete shipment has occurred, an incorrect or incomplete customer order has been done or processed, or for the inquiry of a call, which is the fourth example, it could be a call that is not satisfactorily completed and not solved according to the customer's feedback. So, considering the defect per million opportunities concept, the DPU measurements does not directly take the complexity of the unit to be studied. A more widely used measure is the DPMO, which is defect per million opportunities. So, that basically means very simply like this: you had the total number of defects, Now, you are divided by the total number of units. Now, rather than dividing only by the total number of units, you will also divide by the number of opportunities of such failed cases which has occurred. So, opportunities are the numbers of potential chances within a unit for a defect to occur. For example, on a purchase order, the number of opportunities would be the number of fields in which the information is recorded. So, there can be different type of measurements which have been taken, because each field can either be filled or incorrectly or can be kept as blank. It is important to be consistent about how opportunities are defined as a process, and they may be artificially improved simply by increasing the number of opportunities over time. Generally, in any activity involving measurement, some of the observed variability will be inherent in the units or items that are being measured, and some of this variability will result from the measurement system that are being used. The measurement system will consist on an instrument or gauge, and is often has the components such as the operator that uses it and the conditions at different points in time under which the instrument is used. There may also be other factors that impact measurement systems and performance, such as setup or capability activities which are there. The purpose of the most measurement systems capability studies are to: number 1, determine how much of the total observed variability is due to the gauge or the instrument which is being used, isolate the components of variability in the system, and assess whether the instrument or gauge is capable, what it is capable of, that is, it is whether it is suitable for the intended work which is being utilized. Now, we will just go through the simple concept qualitatively about the repeatability and the reproducibility of the process capability studies or the analysis. So, in this section we will introduce 2 R's of measurement system capabilities and understand them in detail. Repeatability means that we get the same observed values if we measure the same unit several number of times under the identical conditions, point 1, and point number 2 is, which is reproducibility, means how much difference in observed values do we experience when units are measured and they are being measured continuously under different conditions such as different operators, time periods, so on and so forth. Other important aspects of measurement systems capabilities are: the linearity of the measurement system reflects the difference in the observed accuracy or the precision experienced over range of measurements being made by the system, and stability or different levels of variability in different operating regimes are there. So, you want to basically understand that what is the results for warm up effects and environment factors are there, inconsistent operating performance are there, inadequate standard operating procedures are there. So, there can be biases which reflect the difference between the observed measurements and a true value obtained from the master or the gold standard. So, or such that from a different measurement techniques it is basically able is available to us, such that we can take much better readings from the same. So, with this I will end the 33rd class and continue with the 34th lecture, which would continue till the 40th one, and then try to wrap up the course accordingly. Thank you very much and have a nice day.